Hello and welcome to this podcast. Do you want to know more about machine vision software and deep learning and how that could benefit the agricultural sector? Well, keep listening. My name is Iris Hoffman and I work for the agricultural platform Future Farming. I'm going to have a conversation with Mario Bohnacker, who works for MVTec. He's going to tell us more about what this company does and how they work with machine vision software. Hello, Mario. It's a pleasure to meet you. Thank you for being on this podcast.
Hello, Iris. Thank you very much. And it's a pleasure from my side to be here and talk to you today.
Yes, thank you. And you're working for MVTec, and that's a company who manufactures machine vision software. Can you tell me briefly who MVTec is and what you exactly mean with machine vision?
Yes, of course. MVTec is a leading international manufacturer of software which focus mainly on machine vision, and we originated 25 years ago from the Technical University of Munich, and now we have around 200 employees. In these 25 years, we gathered a lot of experience in solving machine vision tasks for a high variance of different kind of industries, like, for example, semiconductor, electronics, logistics, or automotive. So this is what MVTec is. And now, what is machine vision?
Yeah.
Basically, machine vision is what gives machines the possibilities to see. Actually, you can compare it quite good to the way we humans see. We have one pair of eyes, which basically generate image data, visual impression of a scenery. And then we have a second part, which is the brain, which processes this information. So to get information out of what we see. For example, if we go to the supermarket and you look at a strawberry, your eyes take the image and your brain then decides, based on what we see, is it fresh or maybe it's not fresh anymore.
Exactly, yeah.
And for machine vision now, we also have these two parts. And the hardware part is what the camera is, which is gathering the image data. And then we need something like the brain, which analyzes the image. And this is what the software does. So if we compare it to, or if we get back to the example I just mentioned with the strawberry, you can think of your smartphone and you take a picture of your smartphone. So the camera in your smartphone took the image. And then you have maybe an app where some software is integrated. And this software then analyzes the image and tells you, okay, fresh or not fresh.
Oh, exactly. So you also have those applications where you take a picture of a plant or a flower, and then it tells you what kind of flower it is, like that?
This is also another example, exactly. So these are different possibilities. And exactly this kind of software which is needed to analyze the image data or maybe 3D data, and this is what we are specialized in.
Okay, well, that's interesting. And why do people use machine vision? What kind of, what benefits it, for instance?
So as I mentioned, machine vision lets machines see, and this is needed for automation of machines. So machine vision is one key role in the automation and digitalization. And this also means that the benefits of automation are the benefits of machine vision. So why do industries use automation? They want to have lower operating costs, or they want to improve their workers' safety. And there's one example. A few years ago, there was a video in the internet from some factory somewhere over the world where there was a metal press. So big metal parts were pressed into a shape. Mm-hmm. And this press needed to be loaded and deloaded. And this was done by human workers. But the metal press was moving between the pressing. So the workers all had to duck, to go down, to make sure they did not get hit by the press. And
this is dangerous.
Yeah, this is a very dangerous example and a very extreme example of a very harsh working environment for people. But I think no one wants to work in such kind of environments. And by using automation, robots, machine vision, you can make this kind of working area more safe for people by using automation to solve these problems. So this is just 2 examples.
So what makes it interesting for farming and agriculture then?
Yeah, agriculture and farming nowadays are facing more and more challenges, like, for example, labor shortages. So it gets harder and harder to find workers for the hard work. You have rising costs paired with higher price pressure, stricter legal standards and regulation, for example, in terms of the usage of herbicides, or farmland is getting more and more limited. And all this forces farmers and companies to optimize their processes and make them more and more efficient to stay competitive. And other industries, like, for example, automotive, logistics, or electronics, were facing similar challenges in the past and used digitalization and automation to overcome these. And in these industries, machine vision established as a key technology and is already used for decades to optimize these manufacturing processes. And this we can now transfer to agriculture, although the requirements for agriculture are clearly different and also are the benefits.
How are they different?
If you're thinking about agriculture, if you're thinking about farm, it's in the outside. So there's rain, there's temperature differences. If you compare this to manufacturing scenario, production hall, mostly same temperature. Maybe it's in a clean room, so there's not even dirt. So this makes the whole application of this technology difficult, because there might be humidity, there might be water, and this is something which technology usually doesn't work with very well.
No, exactly.
Yeah, so this is different requirements in agriculture. But coming back to the benefits I mentioned.
Yeah.
So using machine vision in agriculture, you can benefit, for example, from the possibility to farm larger areas with fewer people. For example, you can use drones with machine vision to analyze your field, to detect maybe areas where you need to put special effort in as the plants are not growing as they desired. You can use a much more control way of using herbicides to reduce the amount of herbicides used and to save the environmental impact followed by it. You can get rid of exhausting and monotone working steps by automating the harvesting procedure, which also increase the quality of your harvesting and the hygiene standards. You can, for example, also reduce stress and pain for animals. One example is the unautomated milking station. So you use machine vision 3D sensors to detect the odor of a cow, and then to, as gently as possible, automatically apply the milking station to it to force as less stress as possible to the animal by using this kind of machine vision in this scenario. So to sum this up, using machine vision and automation, farmers are able to not only increase their productivity, but also to reduce costs, and they can also cultivate their land more sustainably, conserve valuable resources, and thereby protect the environment.
So it's more, you would say, for example, the milking station you said, there are already like a lot of robots, milking robots. Is there a difference then between what you were talking about and the milking robots who are like used now by a lot of farmers?
Milking robots, how do they work without machine vision? Without machine vision, you put the cow to the position, and then the milking station just manually goes up to a defined position where it assumes where the udder of the cow is located. So this can be right, this can be wrong, depending on where the cow is exactly positioned. If you use a 3D sensor before and you determine exactly the position of the udder, then this can be applied just much more gentle and leads in less stress for the animal. Sorry.
Okay, well, that sounds like something a farmer would like and would want. Can you maybe give me an example of an agricultural business who already uses your machine vision software?
Yes, we have multiple examples, but one example is called Sweeper. Sweeper, exactly. This is developed by the Dutch Wageningen University. And basically the scenario the Sweeper works in is a greenhouse where there is pepper growing. So we have a greenhouse full of pepper plants where pepper is growing at the plants, and they need to be harvested. And usually humans do this. So humans walk by and check if the pepper is ready or not, and then pick. But the working condition in greenhouses, if you do this all the day, high humidity, this it's not too much fun. So they invented an robot, an industrial robot. So not the kind of robot we know from movies who look like a human with eyes and so on.
Oh yeah, no.
Industrial. It's an industrial robot which basically just consists of one big arm, and this robot is moving autonomously inside the greenhouse on some kind of platform with a PC system on it and a battery. And at the end of the robot, at the arm, there is a 2D camera and a 3D sensor mounted, which scan the area. And the robot, using the camera, detects the plants, approaches to the plants, and then uses the camera and the 3D data to get more and more data of the plant and of the pepper on it. And based on the color information, it can detect, okay, where is pepper, because it's different than the green leaves of the plant, and get closer, and then use the 3D data to get an idea of, is this pepper ready for harvesting? Maybe is it ill, or is there any contamination? Is there any bugs on it? And can then decide whether to pick it or not. And if it says, okay, yes, this is a ripe pepper, the robot approaches it. There's a small little vibrating knife, which then cuts the robot at the perfect position that the plant is not harmed. And so this robot just continuously moves through the greenhouse and always harvests the pepper at the exact timing, because there's no delay due to a worker is only working 8 hours and then we have to wait. The impression of is the pepper ripe or not is always the same. So this is mainly the benefits of this application. So this is one very nice example how machine vision here can automate the process in agriculture.
Exactly. And would you say it's more accurate than a human being who is picking the peppers?
I think if a human being is judging a pepper, this is just an impression of this person, and this can fluctuate. Like if you have different persons asking, is this a ripe pepper? Yeah, this is a decision which is not always the same. Also, maybe it depends on the mood, on the current day. I think every one of us has a bad Monday. So if you're in a bad mood and looking at these are always factors which do not appear when you're using an algorithm, because the decision of an algorithm stays always the same standard.
Okay, well, that sounds really interesting, but is it already used worldwide or not?
This strongly depends on the different global areas. So countries which are strongly digitalized are already using this kind of technologies already, but there's still much potential out there. Mainly it's, I think, Western countries which already use a lot of automation in other technologies or industries, which try to use or to adapt this kind of technologies to the agriculture industry also. Yeah, compared to other industries which are nearly fully automated, it is not yet used very much and still at the beginning, yes.
So it's quite new, actually. So it's not used a lot yet, but maybe it's upcoming.
Yeah, I think it's really upcoming. Yeah, because of the challenges I mentioned that's just at the beginning, that it is for the long term, it's a necessity to adapt and to try to figure out how these new technologies and automation can make you profit out of it.
Yeah, and do you feel like maybe people are holding back? Maybe they're not sure what it means and don't really understand it, so choose not to jump into it too quickly?
Yes, I think this is one reason why it maybe is not that used as much as it could be. People are holding back. People maybe don't or are not aware of the possibilities which are out there. So people just don't know what could already be achieved, and are maybe skeptical about the investment they need to take. Another reason is that agriculture and farming have quite long investment cycles compared to other industries. So if you have, as example, the electronical industries like production of smartphones, that the big companies, they release at least one new model of their phone each year, with changed specifications and design. But this also means that they need to buy new machines to produce this new product every year, or maybe they can reuse old machines for the next generation, but at least every 2 years, there's new investment in new machines.
I never thought about that.
Yeah, and if you now compare this to agriculture, how often do farmers invest in new machines? So peppers don't change over time.
No.
So there's no need, except if you have some kind of pressure out of the market, for example, you need to save costs. But I think it's around 15 to 20 years, I guess, in which an investment in the machines is taken. So everyone who invested in new machines the last 5 to 7 years, for example, is not yet ready to invest again in new equipment. So this is also one reason, the big and long investment circles.
Yeah, is it a big financial step for farmers to get into this?
Of course, automation always costs money, and especially due to the harsh environment I mentioned at the beginning. You're outside, you have special requirements to hardware, which does not make it more cheap. But at the long term, it can pay you off, of course, if you get your processes automated. So, we would hope that more and more farmers can see the changes here and see the possibilities that machine vision can bring. And there are several few other reasons why they might be holding back, and this is directly concerning machine vision itself. So I mentioned the harsh environmental conditions and the special hardware which is needed, but also agriculture challenges machine vision software very much.
And why is that?
Yeah, this is just because of the reason how machine vision algorithms are implemented. We can also, again, compare this to smartphone production, for example. So when you think of a smartphone, it has a very specific design. The shape and the desired size is known very exactly, and every smartphone looks like the next one.
Yeah.
So there's a lot of pre-knowledge which you can use, just out of this fact that every smartphone looks like the same. And if you're now thinking of how machine vision algorithms are implemented, basically you can imagine such an algorithm to be implemented like you have an image, and then there is a programmer who types, okay, my smartphone appears black in the image and the background is white. Everything which is black is smartphone. And then the programmer sets up a new rule. I want to measure the width, and says, okay, if the width is, for example, 10 centimeters, it's okay. If it's 10.2, it's not okay. So this measure is also very accurate. And then maybe there's the next rule. Is there a gray area inside this black smartphone area? If yes, okay, I need a new rule, because If this is in circle shape, then this might be dust. So I can clean it. I don't need to throw away this part. But the next rule is the gray area in shape of a line, then this is most probably a scratch and the part is not okay. So the algorithm, that's why we call it rule-based, depends on rules which are manually typed in, programmed by a programmer. And if we now transfer this to a pepper from the example before, then the mentioned smartphone, which always looks the same, a pepper never looks the same. So I think there is no pepper which looks the same.
No, I don't think so. Never saw it, at least.
Yeah, exactly. And you also so to judge if a pepper is good or not good, there's a combination of different things. It's the color, which might be different. The sizes, it can be wider, it can be bigger, smaller, but it's still good. Or the scenario in which a pepper maybe is not good because there is some defect, there is some bump inside, or some part is not good anymore. It's not easy to implement these rules. Just imagine a programmer, he needs to implement, okay, width of 10 is okay, width of 20 is okay, color yellow is okay, color yellow greenish is not okay. This is just impossible to implement for all the possibilities how this pepper looks like, and this fits to all natural grown products.
Yes, and that's what you call deep learning, right? What you just explained.
Basically, deep learning, as you mentioned, is the solution why machine vision now also can be used in agriculture more and more. Because for deep learning, you don't need to have this programmer who types in all these rules. Deep learning basically works like a little bit the human brain or a child learning in school. You present a picture of a good pepper and you tell the kid, this is how a good pepper looks like. And then you present images of this is how a bad pepper looks like. And then you, repeat this for hundreds, thousands of images, and the algorithm by itself learns how to differentiate between good and bad. And this especially helps for these natural shaped products in which it's not possible to manually define, okay, this is the reason why this is good or why this is not good.
Exactly. And you say, you compare it to a child, that takes a very long time, years to actually know, like, this is good, or maybe this means that it's a little bit rotten or something, or, whatever. Does it also takes a lot of time for this software machine to understand all of it, like if it's good or not good? Or
yeah, of course it needs time, but the good thing is there is a lot of hardware out there with a lot of computational power. And this is what we profit on using deep learning. So we have a huge number of images which need to be computed, and they are computed over and over again until the algorithm learns. This takes time, but the hardware out there, graphical processing units where deep learning is trained on a lot of times, there's special hardware only for deep learning purpose. This can solve such kind of tasks, in hours, not years. So
that's less time.
Yeah, exactly.
Okay, great. But I do hear a lot about deep learning. Isn't it just a hype topic everywhere in the media or something? Or
I think this strongly depends who you ask. If you look out there in the media, you can get the impression that deep learning is everywhere, and this is also what we see at fair trades. For machine vision, everyone is advertising with deep learning.
Yeah,
and in a lot of application examples, this works quite well, especially also in consumer areas like smartphone. Again, just an example everyone knows. Deep learning can be perfectly used to sort or to categorize images in your photo gallery. Like in most smartphones you open, you just enter cat, and then you get all images which contain cats.
Exactly.
So this is working quite well, but if we want to bring this in industrial context, the requirement is a little bit more challenging than sorting cats and dogs. This is where it gets tricky. And we see deep learning as a very important new technology, which is adding new possibilities for machine vision. But we do not see it as the one-stop solution you can throw any problem at. Of course, it enables and opens up huge fields of possibilities. But in our opinion, it's always a combination of existing technology and deep learning technology. And actually, the example I introduced before with the sweeper and the paprika stuff, this is also combining traditional machine vision algorithms with deep learning. So we have a robot with a camera, and this usually needs some calibration matching, that the camera position is matched to the robot position, so that they know from each other, okay, if I look here, where am I located? This is traditional machine vision algorithms. The 3D processing, which was done here to find the object and to get its shape, this is also done with traditional machine vision algorithms. The classification of is the pepper ripe or not, this was done with deep learning. So there is one part of the complete application where deep learning is added, but the rest of the application is still existing traditional machine vision. So we always consider deep learning as one part of the solution, and if we combine it with the, let's say 25 years of experience we have with traditional machine vision algorithms, then we can get the best out of these both two new worlds.
So the deep learning is actually a small part of the whole machine vision technology.
Yes, in our interpretation, yes. So for us, it's always just one part of a solution of a real world problem. So it's not always easy as just like, if you have this cats and dogs example, I always like to use this. For you as a user, it's only, I want to know if it's a cat or it's a dog. But if you're looking at an application in an industry, as I just mentioned, there's more behind. There is communication to other hardware parts. There is maybe some post-processing of the information, or what do I do with the information that it's a cat or a dog. And all this combined gives one whole application where deep learning is one part which helps to solve the problem.
And if we translate this back to agriculture again, can you just like paint me a picture? Because I can't put it like on my tractor, like a big PC on my tractor or something, right? So like how would that work?
Yes, that's right. It's not too easy to put a big PC with a lot of computational power on a tractor. But there are several possibilities to overcome this problem. And one of them is called embedded vision. And with embedded vision, we mean embedded devices, which are in principle small or mini PCs in very, a PC in very small dimensions with enough computational power. Of course, not the same as maybe one big tower PC, but enough computational power which is needed to solve several tasks. And actually, the funny thing is that this is also triggered, so the development of these embedded devices is also triggered by the smartphone or the consumer industry, as the smartphone basically is the same. It's a very big, powerful computer in a very compact form. And the development of smartphones, they came out in this compact format. And for consumer market, and an embedded device, which we use for embedded vision, is basically the same, just for the industrial use case. You don't have a touch panel at the beginning, because this is not necessary with embedded devices, but the rest basically is, you can imagine, small PC version. And this can then be easily attached to a tractor and used on the field. One example application we have in this area is a tractor which is moving over a field, and behind it there is a big sprayer which sprays herbicides on the field. And usually you would spray the complete field with herbicides and use quite a lot.
That's just a waste.
It's just a waste, and it might not be necessary. And using machine vision, you could put cameras onto this sprayer. You could put an embedded device next to it because it's not too big, it's not too heavy, it has quite low energy consumption. And then the camera looks at the field, and with using deep learning algorithms, you can detect whether there is crops which you would like, or if there is some weeds which you want to remove, of course. And if the camera detects these weeds, it triggers it gives the image to the embedded device. The embedded device does the calculation, weed, no weed. And if there's weed, it puts the trigger to the spray, which then sprays at the exact moment where the spray arm is over this position. So you can do a targeted application of herbicides, which reduces, of course, the environmental impact of herbicides. You save herbicides, you save resources, you save costs, and the result is you have a high yield and best quality. I think all the consumers worldwide tend to, desire products which none of these herbicides are used too much. So this is one example of how you can overcome this.
Oh, that's kind of funny because I used to work in Australia for a couple of months on a really big farm with crops and stuff, and I used to drive this big tractor with a sprayer behind it, and it would also, I think, kind of like the same software where it detects the weeds and just only sprays that part. It was really easy for me to use, but I never understand how it worked or something. But for me it was really easy. But
you can see that it always sounds very, let's say, difficult and technical. And it is to get such kind of solution. But in another way, all this technology can be made available for the ones who are using the tractor in a very simple way. In the most simplest way, it's just a start and stop button, or maybe you add a little bit more to the system to set up a few parameters. I don't know, the amount of herbicides which is used and so on. But it sounds difficult, but it can be made available for everyone who is using it.
Yeah, and I understand that you guys are making the software, but that doesn't go immediately to the farmer, right? There is something in the middle.
Yeah, correctly. So our software, which is analyzing the images, in some way needs to be integrated into this kind of different kind of machines. So we are not a company who is producing tractor software or only tractor solutions. We are providing standard software, and the companies who provide these tractors and then integrating our functionality in their systems, and they also know what the people who operate the systems, who use the system, want to know or want to have control of, and can then present only the necessary information to the user and make it as user-friendly as possible.
Yeah, so they translate it to the farmers or other users and stuff. Yeah, exactly. Okay, Mario, but to sum this up now, why do you think machine vision is needed in the future of the agricultural industry?
Yeah, first of all, I want to mention that we do not think that agriculture will completely be changed by machine vision or automation. So there's a revolution going on or something like this. It's more like a constant change where applications become more and more complex. And that's why also the demands for the workers are kind of shifting. So, for example, you had seasonal workers for harvesting, And now or in the future, you will need workers who can operate this new kind of machines. So there will still be the know-how needed in the agriculture sector, but it kind of shifts. But yeah, nevertheless, agriculture industry is facing more challenges in the future. Like, for example, the population growth. There is more and more people on the planet which want to get something to eat. We have labor shortages. We have very exhausting working environments, especially in agriculture industry, where it's very difficult to find people which are willing to do this work. And especially if you think about the last 2 years facing the COVID situation, where also there was a high lack of people for such kind of work. Yeah, automation and machine vision is a key factor here. And last but not least, a sustainable and eco-friendly farming is one important topic, as more and more people demand sustainable animal-friendly products. They want to make sure that the products they buy reduce less amount of herbicides, and that everything keeps the environment safe. So all these are reasons why we think that agriculture and farming industry has to think about the future possibilities of automation and the use of machine vision.
I think you make a really good point there, Mario. Thank you very much for your story and for this podcast. And I really enjoyed talking to you.
Yeah, thank you very much also. I really appreciate to be able to talk to you about this topic. And I hope that a lot of listeners are interested in this topic and like this podcast.
Do you have any questions after listening to this podcast? Mario and his colleagues will be happy to answer them. You can send an email to info@mvtec.com or go to the website mvtec.com to ask questions or to evaluate how specifically you can benefit from it. You can also check the white paper in the link below this podcast. Thank you for listening, and I wish you a very good day.